Welcome back, grade 8. I really want to go to bed, but instead I am making you a video and I am missing out on some serious kitty snuggles at this moment in time. In today's video, we're going to be learning about the quotient law. So let's ask ourselves the question, how can I simplify these two here? So here we have 6 to the power of 5 divided by 6 to the power of 3. Now remember, we learned that division is just like fractions. So really, we could rewrite this as 6 to the power of 5 over 6 to the power of 3. And then if we really want to understand this rule, then we should expand this out. So 6 to the power of 5 we know is going to be 6 times 6 times 6 times 6 times 6. And then we know in the denominator, 6 to the power of 3 is 6 times 6 times 6. And then what's really interesting here is if we look at this part here, well, it's 6 divided by 6. So really that's 1. And then we have another 6 divided by 6, so that's going to give us 1. And then another 6 divided by 6, which is also 1. So if we look at this expression now, what we're left with is 1 times 1 times 1, and then times 6 times 6. So remember that anything times 1 is just itself, so really we're just left with 6 times 6. But if we're using exponents to simplify, we have 6 squared. So we can do the exact same thing for the second one here. We've got 2 to the power of 6 divided by 2 to the power of 2. So again, we have a fraction, 2 to the power of 6 divided by, or over, 2 to the power of 2. And then which is equal to, we can expand out the top, so we've got 6 2's. And then expand at the bottom, so we have 2 2's. And then we see the same thing. We have 2 over 2, which is 1, another 2 over 2, which is 1. So what are we really left with here is we've got 4 of these 2's, so that's just 2 to the power of 4. So hopefully, by looking at how this was expanded out, can you guys determine what the general rule would be if we have division of exponents with the same base? So hopefully, you saw that when we're dividing with the same base, what's happening is we're subtracting the exponents. So if we look at this one here where it's 9 to the power of 8 divided by 9 to the power of 5, well, we're subtracting the exponents, so really we have 9 and then to the power of 8 take away 5, which is going to give us 9 to the power of 3. And if we take a look at this one, 2 to the power of 4 divided by 2, don't forget that there's that invisible 1, so really it's like 2 to the power of 4 divided by 2 to the power of 1, which is just going to give us 2 to the power of 4 subtract 1, which is 2 to the power of 3. Now, notice that I'm writing down the operation that I'm doing in the exponent, and there's a reason why I'm doing that. Because now if we look at for the next one, which is 3 to the power of 5 divided by 3 to the power of 7, notice for the last two, the number that's first in my subtraction is also the first number that comes in my division problem of the exponent. So for this one, 3 to the power of 5 divided by 3 to the power of 7, I should be doing 3 to the power of 5 take away 7. So we have to be very careful with that. So we get 3 to the power of negative 2. And then if we take a look at the last one here, we've got a to the power of 3 divided by a to the power of negative 5. So again, I'm going to write this out as a to the power of 3, and I'm subtracting the exponents, right? So it's going to be a to the power of 3 subtract negative 5. So just be careful there. We've got 3 subtract negative 5, and we're going to get now a to the power of 8. So let's take a look at our first examples. We're going to be simplifying these expressions. So in number 1, we have 6 to the power of 7, and that dot there just means multiplication, times 6 to the power of 3, and that's a fraction over 6 to the power of 5. So now we're combining what we learned last week on top of the stuff that we've learned this week. So we've got on the numerator, 6 to the power of 7 times 6 to the power of 3. Remember, when we're multiplying with the same base, we are adding the exponents. So we've got 6 to the power of 7 plus 3, and then over 6 to the power of 5. And we can evaluate that top part, so we get 6 to the power of 10 over 6 to the power of 5. And now we can see that we're dividing with the same base. So we've got 6 to the power of 10 take away 5, and then we're left with 6 to the power of 5. So taking a look at our second one, again, we've got m to the power of 8 times m to the power of 6 over m to the power of 5. So we're multiplying on the numerator so we can add our exponents. So m to the power of 8 plus 6 over m to the power of 5, and then we can evaluate the numerator section, so m to the power of 14 over m to the power of 5, and we get m to the power of 14 take away 5, which we get m to the power of 9. So now that we've gone over those two examples, take a moment to try these two out on your own. Alright, so taking a look at our second example, this is take 2 by the way, looking at number 1, we've got d to the power of 5 over d times d to the power of 9 over d to the power of 8. Now what we've got here is we're multiplying two fractions, so we did learn that if we're multiplying two fractions, we can just multiply the numerators and then multiply the denominators. So we can do that. So we've got d to the power of 5 times d to the power of 9 over d times d to the power of 8. Now we're multiplying with the same base, so we can add our exponents. So we've got d to the power of 5 plus 9 over d to the power of 1 plus 8. Remember that there's that invisible 1. So now we get d to the power of 14 over d to the power of 9, and now we are dividing, so we're going to subtract those exponents. So we've got d to the power of 14 take away 9, and we get d to the power of 5. Now, we've been learning about how there is always more than one way to doing a question, and for these ones, there is more than one way to do these questions. So we can actually look at number 1 a little bit differently. What we could do instead is we could also look at this first fraction and simplify this first fraction. We can see here that it's being divided with the same base. So we could do, well, what's d to the power of 5 divided by d? And we know we're subtracting with the same base because we're doing division. So that's d to the power of 5 take away 1. So this expression here is just d to the power of 4. And then if we look at the second fraction here, we've got d to the power of 9 divided by d to the power of 8. So that's just going to be d to the power of 9 take away 8, which is just going to be d to the power of 1. But we don't need to write the 1, so it's just d. And then we've got our two expressions, and now we can multiply them. So we've got d to the power of 4 times d to the power of 1, which is d to the power of 5. So we've got two different strategies here, and both of them give us the same answer. All right, so looking at our second one here, we've got these two fractions that are being multiplied with each other. So we could multiply the numerator, so we get p to the power of 3 times p to the power of 6 times p to the power of 4, and then we can divide that by p squared times p. Now we're multiplying everything with the same base, so we can add those exponents. So we've got p to the power of 3 plus 6 plus 4 divided by p to the power of 2 plus 1. And then if we evaluate that part of the exponent, we just add those numbers, we get p to the power of 13 over p to the power of 3, which gives us p to the power of 13 take away 3, which is p to the power of 10. Now, of course, just like the last one, there's more than one way to look at this problem. So I'll go over just another way of doing it. And there is a third actual way if we think about this as well, but we'll just go over a second one. So if we look at this fraction here, we can really actually break up this fraction into two parts. I can split this up and put p to the power of 3 over p squared times p to the power of 6. So then if I did that, I had p to the power of 3 divided by p to the power of 2, which is just going to be p. And then I have p times p to the power of 6, which is going to give me p to the power of 7. And then if I look at this other fraction here, I can look at this and I've got, they're being divided, so we can subtract. We got p to the power of 4 take away 1, and then we get p to the power of 3. So then we have our two separate parts. We can do p to the power of 7 times p to the power of 3, and we are multiplying with the same base, so we're going to add. So we're going to have p to the power of 7 plus 3, which gives us p to the power of 10, and then again, two different strategies, same answer. All right, so for number 2, I did say that there were a third method. There's probably even a fourth. I'm just seeing right now a third different strategy. So hopefully you can take and apply some of what you have learned in this video to think of a third strategy. So now I'm leaving you with 2 more try questions for this video to test out what you learned. Good luck!